So now I want to look at one more example, looking at another graph to determine if y is a function of x. All right, and so for me to do this, I'm going to make sure that we're aware of some things here. Here I have a closed circle. Here I have an open dot, an open point. So this is open. This is closed. That's closed. This is open. So I'm going to make it a little bigger so that we are all together. And this point right here is open. Everything else is closed, 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 closed. Right? Open circles mean we don't include this point as a value on the graph, right? So the point that has an x coordinate of -4 that my function passes through is the point -4, -2. This graph does not contain the point -4, -4. It is an open circle, okay? And so now that I know that information, if I want to determine if this is a function, y as a function of x, then I just apply my vertical line test. Vertical line, vertical line. Notice here, the only places where I can possibly not pass the vertical line test is at these points where we have this overlap of this closed circle and this open circle, right? If I drew a vertical line here, it still passes the vertical line test because only this function, right, this point right here, the point 4, -2, is a part of the graph. 4, -4 is not. So it still passes the vertical line test. And since both of these come in pairs of open and closed circles, I passed the vertical line test here, and I passed the vertical line test here. And of course, in these line segments, I passed the vertical line test as well. And so I'm going to say yes. It passes the vertical line test. Okay. One of the things that I want to review in this video is also how do we write values in our domain. For instance, let's talk about finding the domain and range of this function looking at the graph. All right, so looking at a graph, how can we find the domain and range of a function? There's multiple ways to think about this. I want to think about it in relation to ordered pairs. When I want to find my domain is always my set of all x. When I have a graph given in x and y, right? So it's your set of all x where the function is defined. And so one way that I like to think about it is almost as using my x-axis as a magnet that pulls my function up or down, for instance. If I start from -infinity, which is over here, there's no part of my graph that's at -infinity because I don't have arrows here. I have an endpoint, right? So my graph kind of starts with the smallest x value. The point with the smallest x value right here is -6. And that's a closed circle, right? So if I were to think of my x-axis as a magnet and I look at this part of my graph here, what I'm going to have is this part of my number line covered, and if my graph or my x-axis is a magnet and pulls everything towards it, then all the points here would be covered until I get to this open circle right here, right? So this part of my line, if I were to write this in interval notation, remember interval notation, we start from left to right, and I can write this as -6 all the way until I get to -4. Notice -6, I had a closed circle here, so I'm going to use a bracket. But at -4, I had an open circle, so I'm going to have a parenthesis, right? So the interval, this is interval notation for the point -6, -4. I include -6, so I use a bracket. I don't include a -4, so I use a parenthesis. Now I'll go to this next part of my graph, right? Which is this horizontal line, right? Notice it has a closed circle here. That's at the point -4, -3. I said -2 earlier, but I meant -3 here. So what I would do if I think about my x-axis as a magnet to see what my domain is, I'll pull everything about this horizontal line all the way up to my x-axis, and I see that I close this. All of these points here are covered, 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 covered until I get to x equals 2, and at this point in my graph, I have a closed circle, right? So this part of my graph is represented by the interval -4, comma 2. Since those are both closed circles, I use a bracket around it. The next part of my graph is this diagonal piece here. Notice to the left I have an open circle on this diagonal piece, so I have an open circle, but it's already closed. But if I were to write my domain, it would have an open circle here, and I will pull all these points here up to my x-axis, so this part is going to be covered, and these parts that are over here will get covered down all the way until we get to 4. I have a closed circle. And in interval notation, this piece right here would have a domain represented by 2, 4 with a closed bracket at 4 because that circle is closed at 4. Okay. Then I have this diagonal piece up here, which starts with an open circle. So at 4, I would have an open circle for this piece, and I think about my x-axis as being a magnet. All of these points would be covered until we get, so from 4 all the way until we get to 8, closed circle. So this one will have a domain of 4, 8, use a bracket around 4, parentheses around 8. Okay. Well, now that I have each of these pieces here, all right, I just want to review when we use parentheses and brackets. And notice, anytime we have like negative infinity, we'll have a parentheses, or if we have a positive infinity, we'll always use a parentheses. Those aren't distinct values. But now that if I want to write my domain, then what I'm going to do is go from left to right and see whatever is closed. So I have -6, although at -4 it was closed at one point, it is closed at the other point here, so I include -4, so I'm going to continue. Notice here I was closed at 2 at one point and open at the other. If it's closed at least 1, it's going to remain closed, right? Here at 4 it was closed at one point and it was open at the other. Since it's closed, it's going to remain closed. And then at 8 it was closed. So every number from -6 to 8 is used as an ordered pair to a point, an x value in an ordered pair to a point on this graph. So my domain is -6 to 8. And I use a bracket around 8. You can't see the graph anymore since I wrote all that stuff. But what I'm going to do is I'm going to try my best to undo everything that I did so that I can see the graph again. So let's see if it's going to let me, how far it's going to let me go back. It didn't let me go back very far. So I'm going to redo what we just did. We say my domain was from -6 to 8, included. And then my range is the y values where my function is defined. So now I've got to think on the y-axis, what are my ordered pairs? So if I start from the leftmost point, it's -5, which is this point right here is closed. Then I'm going to be covered up until we get to -4, that's closed. Then my graph skips, and I'm at this point right here, which is -3. Then my graph skips again until I get to -2, and it's open at -2. So I'm going to have an open circle at -2. All my points are up until I get to x equals 1, and at 1 is closed. Then it skips until I get to this point right here, which is open at y equals 2, and I go up to 3 and close it, and it's all the points between there. Okay, and so if I want to write my range, I'm going to have some steps in my range, right? I started with a closed circle at -5, so I have the point -5 to -4. I'm going to have an open circle here. That's the open circle at -4, right? Then my next set is the point 3, x equals 3, -3, or sorry, y equals -3. That's a single point. So all the points on this horizontal part has a y coordinate of -3. So -3 is in my range, right? Then I skip up into -2, but I don't include -2. So I'm going to have a parenthesis, -2, and I use all the points as y coordinates up until I get to y equals 1, and that's going to be a bracket around 1. Then I skip up to 2. I have an open circle at 2 and a closed bracket at 3. Now, I put a space in between these because my range includes any value between -5 and -4, including -5 and not -4. This symbol right here means union. The set that contains -3 is just a distinct number. That's why I put it in a squiggly bracket. Union -2 to 1, including 1, union 2 to 3. And so that is my range. So I want you to be able to come up with values of your domain and range by looking at a graph, and we'll talk about how we can do that algebraically.